What should we do? Where should we start? I think I'm going to start by turning my fume extractor on. I'm going to put some gloves. I'm going to put my sleeves up. And then we're going to do this. Bruce Lee style. Here we have a Nintendo Switch that came in for repair. We already disassembled the board right here. And I can tell by just looking at the board that somebody worked on this motherboard before. If we read what the customer wrote, my tattoo artist's son's switch stopped charging. How many S's? Artist's son's switch stopped charging. He took it into a local shop to have it repaired, and they said they made an attempt to replace the chip, but were not successful. After opening the switch myself, I noticed a solder ball where in your video there is a cap, like it's missing. If you can please figure out what is happening and get it working, that would be great. None of his kids' game saves are in the cloud, so they lost all their progress. So here we have a case of not only fixing the switch, but more like data recovery. They care about the information inside because none of the game saves are on the cloud. So this answers a lot of questions we always get. Why is that customer fixing that device? Why is that customer fixing that flash drive? The flash drive alone is $10, $12. Why fix the flash drive? Do you think the customer mails over a flash drive, he spends $15 in shipping for the flash drive to come here so they can fix it, so they can fix a $12 flash drive? No, it's the files inside the flash drive. Same goes here. They care about the game progress. They do not have the game progress saved, and that's why they want to fix this motherboard. Just like that customer who came in with a Nintendo Switch, and she was willing to pay up to $1,200 to fix her kid's Switch. She said that her kid has 2,000 hours play on that game, and he does not want to lose his progress. She sent it over to Nintendo. They were not able to help. She took it over to a couple of shops. They were not able to help, and they sent her over to us. I was not able to help either because the Switch was in a very bad condition. It fell in the tub and water was everywhere. Everything was corroded, and the Switch was just not fixable. But 2,000 hours on that Switch. Her kid spent 2,000 hours on the Switch. If that kid is playing 8 hours a day, how long will it take him to do 2,000 hours? That's 250 days worth of play. That's if you are doing 8 hours a day. So the kid is doing nothing but playing games. That's bad. That is bad. I tried to help her. She's a customer, but I was not able to. Let's go under the microscope and see what's going on, because I see almost a Hiroshima on this board. Meter in diode mode. And we have a short right here. We have a short right here, and the short is likely coming from the chip, from the BQ chip. We can tell the USB-C connector has been changed, replaced, or maybe tampered with. I see factory soldering here. Factory soldering here, so I do not think this connector was replaced. Maybe they applied solder onto the pins in the front, but I do not believe the connector was replaced. If we flip the board, yeah, this looks like factory soldering. This right here. We may have to change that port, even though the pins, they look solid from the front. The connector does not look good, but I'll keep this until last. We're not going to do it now. Maybe the port or the connector is good. This looks off, but it's making a solid connection, so keep it. And while at it, why not measure it and see if we have a continuous path? And we do. Going up here, we see a blob, a nice, shiny, round blob. If we measure this cap, do we have a short here? We do not. We do not. We do not. I'm not getting any reading, and we should have a reading here, but I'm not getting any reading. Oh well. Oh well. Actually, this one is showing 0.5. This one is showing OL, and this one is showing OL. Only 0.5 voltage drop on this cap right here. What if we measure this one? No reading. Oh well. Wow. It could be that the chip is not even making a connection, and that's why we have all the OL readings. And if we measure here, we have 0.45 voltage drop, and that's nice, but not enough. Let's continue with the inspection. At least The CPU plate is not removed, so we know this area has not been tampered with. If we look at the LCD connector, just make sure the LCD connector is good. It looks good. SD connector looks good. Backlight connector, Joy-Con connector. I do not see any issues here, unless we do have an issue. And we do not have a short 0.13 voltage drop. If we flip the board, of course we have flux on the P13 chip. What do you think? We're gonna have flux all over the board and we're not gonna have flux on the P13 chip? And I do not see anything else wrong on the board. What should we do? Where should we start? I think I'm gonna start by turning my fume extractor on. I'm gonna put some gloves. I'm gonna put my sleeves up. And then we're gonna do this. Bruce Lee style. Apply genuine Amtech Flux. This actually, I'm not gonna worry about the connector right now. Let's worry about this area. If it's not broken, don't fix it. Unless we have to. Now we have a lot of glare and reflections on the board because of the flux and because of the work that was done on the board. So we're gonna turn on our anti-glare light. Just like that. Beautiful. Whatever we are using here, flux, the anti-glare light, the microscope, tweezers, braid wick, all the tools that you need. Hot air station, soldering station, thermal camera, voltage injection tool, power supplies, charging stations. We have all items in stock. You can log into NorthridgeFix.com, click on shop, add whatever you want to cart, check out, pay, and we almost always ship out your orders same day. Very easy. So we got rid of that blob. We're gonna have to replace that cap that is missing here. And of course, we're gonna have to remove the chip. I do not see any solder anywhere on that chip, and that's why we were getting OL on a lot of the caps that we measured. Not enough solder on here. I do not know if that M92 chip is good or not, but let's assume the chip is good. Let's assume. Maybe whoever worked on it, they already replaced it, and there's no reason to waste it. But we're gonna be wasting time. If we put on that chip and it was the cause of issues, then we would waste time. But for the sake of this video, let's keep the same chip. Just a tiny bit in the center here, and that's enough. Enough solder blob in the center because we're gonna squeeze out the access anyway. So we have enough solder on all the pads. Just apply a little bit of flux. When I say a little bit, I mean a lot. And we have to orient the chip the proper way. Pin number 1 should be top left. Top left as I have the board oriented. And let's do it. And again, we are assuming the chip is good. Very nice. Now we're gonna push down on the chip, and we're gonna apply more heat, and we're gonna squeeze the guts out of that chip. All right. So let's go ahead and measure again and see if we still have OL on a lot of the caps that we measured before, especially cap number 1. and we no longer have an OL. We have 0.33 voltage drop. We have 0.48 voltage drop. Now the board is still burning hot, so the reading may be off a little bit, but we are getting a reading right here, 0.33, 0.34. It's going up slightly. We have 0.49 here, and we have 0.33 here. So we already fixed the OL issue here, and we have 0.43, and we have 0.4. Awesome. So this area is done. If we go back here, do we still have a short on this guy? And we do. So we're gonna have to replace the BQ chip, because most likely the short is caused by the chip. I'm not seeing a short here. I'm not seeing a short here. I'm not seeing a short here, not here, and not here. So we know that our next chip is good, because in a previous video I worked on a switch that did not power on. We had a short circuit right here, and that short circuit was because of this max chip that you see here. We're gonna replace the BQ chip and hope for the best. Right now we cannot plug a battery and try it because we have a short circuit. Anytime you have a short circuit on the board, you need to fix that first, unless you're asking for trouble. So right now we're gonna point hot air away from the plastic connector that we have here. We do not want to burn it. And let's replace it. Chip is out. And pin number 1, as I have the board oriented, is top left. So pin number 1 should be right here. Genuine Amtech Flux. You're not gonna get a better flux than Amtech 559 by Inventec. We are a distributor of the flux. It holds very well under heat and easy to clean. We sell the 559 and the 213 models. The 559 remains the standard, but 213 I would use it if I have a very crowded area, a lot of components, a lot of microscopic components, size 105, size 201, 402, and they made the 213 even easier to clean, but it does not hold very well under heat. It evaporates quick because of the formula. You can also use 213 here. It doesn't matter, but I'm using 559. And we have enough solder on all the pads. All we need to do right now is grab a chip, and it looks like I am out of the BQ chip. Let me grab one from inside, just a minute. Let's put that chip, just like that. Now the blob in the center is a lot. What's gonna happen is that blob is gonna squeeze out and it's gonna short out some of those capacitors. So to prevent this from happening, or to avoid this from happening, let's wick off part of that blob in the center. That's good enough. And like I always mention, work smart and not hard. So why create more work for yourself when you can prevent issues from happening by taking some measures that will take you only a few seconds. Let's apply some flux. Very nice. Now we're gonna have to squeeze the guts of this one too, not just the M92, because everyone is equal. That's what being fair is all about. Beautiful. Let's remove this. Now, one thing we forgot to do was measure the capacitor when the chip was off the board. But now that we soldered the chip on the board, that's what happens when I'm recording a video. We're gonna measure that capacitor right now. What? We have a short still. The cap is going to the chip. We replaced the chip, but we still have a short. What's going on? Let me measure in resistance mode. That's that short, 0 ohm short. Wow. Is it possible that maybe our connector is what's causing the problem? Because the connector is directly related to that chip. I highly doubt the connector is what's causing the short. What we can do is inject voltage at the shorted cap, and we can monitor the board under a thermal camera and see what gets hot on the board. And we'll take it from there. Let's go to our voltage injection tool, turn it on. And we're gonna set voltage to, let's set it to 1.2 volts. I currently have it at 1.44, 1.2, good. I have the tone on, so when I dial the voltage, I hear a tone every time I dial. And the voltage increases or decreases by 0.1 volts. So if I press once, 1.5, 1.6, 1.7, 1.8. I just went back 2, so we are at 1.6. I do not even need to look. 1.5, 1.3, 1.2. And now we are at 1.2. Okay? And look at this. When I inject voltage at the cap, we have a weird line that appears right here. Just look at this area. Look at this area. You see? Oh, wait a minute. We have a bridge between this component, this end of the component, and this end of the component. That's what's happening. You see how tiny things can send you into a never-ending loop? But we got it quick. We're gonna replace the cap here, but let's see if we still have a short on this cap. Zoom out. Do we still have a short circuit? And we do not. Meter in diode mode. I measured in resistance, and resistance was high. So right now we have 0.49 voltage drop. Awesome. You see? Maybe we did not have to replace this chip. The only reason I replaced it was because we were reading a short here, and this component is connected directly to that chip. If we focus here, we have ground on this point, and we do not have ground on this point. They were bridging, creating a short. And that's why we read a short right here. So this chip was probably good. What can you do? Part of the job. Sometimes you waste time for nothing. One last thing we need to do is replace the cap or solder a replacement cap, since we do not have that part on the board. And then we're gonna test. And we're gonna grab a donor Nintendo Switch board. Hopefully we can get that component from there. Yes, right here. Beautiful. The cap is in place. Moment of truth, we're gonna plug in a battery and we're gonna plug in a charging cable. How will I know if that motherboard is working if we did not reassemble it? I know from this amazing charging station right here. If we see 12 volts, 0.6 amps, and then it switches down to 9 volts around 1.5 amps, it means we have a working board. If it got stuck at 12 volts, 0.5 amps or 0.6 amps or 0.7 amps, and it did not switch down to 9 volts, it means the motherboard still has issues. So hopefully we have a working board. I have the battery connected right here. And we're gonna plug in the cable. Tap to wake, 12 volts, 0.6 amps, and after a few seconds, it should turn off and switch down right there, right there. 9 volts, 1.6 amps. Yes, we did it, we did it. 9 volts, 1.6 amps, amazing. Before we end the video, let me just, maybe we can reassemble it quick. I'm just gonna reassemble the most important wires. backlight, screen, power button, power flux, and battery. And then we'll test again. Big Boss is not here, he left. Right now it's 6:15. And I just want to finish this video and go home. That's where Big Boss shines. Where is Big Boss when you need him? You only know the value of Big Boss when you have to take apart or reassemble a device. That's why I call him the boss of all bosses, because he's quick, efficient, and I cannot keep up with him. We worked on about 15 devices today, and look at this, look at my bench. He put the laptop here, Asus laptop, to fix. He put another board here to fix. This laptop is already fixed. Video card. And a lot of stuff that we have here. I told Big Boss not to overcrowd my bench because it's overwhelming. But those are all expedited and we have to finish them as soon as possible. Alright, so the screen cable is in. Let's connect the backlight cable. Where is Big Boss when you need him? Now, assuming I connected the screen cable properly, backlight cable properly, power button properly, all we need to do is plug the customer's battery, and the customer has a brand new battery, a white one right here. So let's turn it on. Unless the customer's battery is dead, and it looks dead. I do see a hairline crack on the screen. So what is not wrong with the switch? What's not wrong with it? We're gonna plug the charging cable. Tap to wake up, 12 volts, 0.6 amps, and we have to wait until it goes down to 9 volts. And it did not switch down to 9 volts. It's stuck at 12 volts, 0.4 amps. That's not good. But we already know that with our battery, it did go down to 9 volts. On the customer's battery, it's stuck at 12 volts. Customer's battery is also faulty. Talk about what's not working on the switch. Customer's battery is stuck at 12 volts, 0.4 amps. And it's a brand new battery. Let me disconnect the charging cable. We're gonna connect our battery and we'll test again. I connected the battery, backlight cable connected, screen cable connected, power flux cable connected, and all we need to do is connect the charging cable. 12 volts, 0.6 amps, and right there. Let's wait. Yes, 9 volts, 1 amp, or 1.7 amps. And done. Wow, we fixed it. We did. I mean, I did not have to reassemble the board to know that the board is working, because based on the charging station, I know it switched from 12 to 9 volts, 0.6 amps to 1.7 amps is a fix. It's a good board. Let me disconnect our battery, and I'm gonna put this on Big Boss's bench so he can replace the battery for the customer and reassemble the console. Then we can invoice and mail this back to the customer. I hope you enjoyed the video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.